Hello. So today we're going to be talking about reflection, and this is going to be the example of reflection. I'm going to explain what reflection is and what reflections really is. So reflection is bouncing off of a surface, and this is going to be an example of what reflection really is. This is a reflection of light, and I'm going to be explaining what it is and what it really is. So this is going to be a mirror, and this is the incident ray, and this is the reflected ray. And this is the angle of the reflection over here, and this is the angle of the surface, and this is the normal phase of the surface. So we're going to be explaining what it means and what this really means. So the incident ray is going to be about like the decline, the surface facing the mirror, and the other side is the reflection coming out of the mirror. So it's going to be a reflection of light, so the light coming towards the mirror, bouncing off of the mirror, which is the surface. The mirror is the surface, bouncing off of the mirror and going the other way as a reflection from the mirror. So it's bouncing off of the surface. The surface is the mirror, and it's bouncing off the surface. This is it bouncing off the surface. This is the reflection. This is the reflection, and it's bouncing off of it, which is a reflected ray. And this is basically what it's trying to explain to you, is that this is the mirror, which is the surface, and this is the incident ray, the angle of the surface facing towards the mirror, and it hits the mirror, which is the surface, bounces off of the surface, which is the angle of reflection. It's reflected off of it, meaning it bounced off the surface and it came off of the surface. This is a reflection of it. This line is the example of it, and it's pretty much what it means, reflection of light. And you can use it, there's many examples of it's not have to be just light, but I chose to use the example of light, and that's pretty much it. Hello. So now I have already explained the reflection of light. Now we're going to be explaining refraction, the refraction and refraction of light. So this is going to be the example and explaining what refraction is and how it is and how it's used and what it actually is. So refraction is, it bends by changing speed at a new medium. So this is the example. This is the normal surface of the normal, and this is the 90 degree. And this is the incident ray. This is the incident ray, and this is the angle of reflection right over here. It bends over here. This is the reflected ray. This is the angle of reflection. This is the angle of the reflection of it. And this is the boundary. Right here, this is that line is the boundary. And this is the incident ray. And this is the angle of incidence. This is right over here is the angle of incidence. And right here is the 90 degree box right over here. And we ignore that because this is right over here. This is the line. This is the incident ray, and this is the angle of reflection. So refraction is it bends by changing speed at a new median. Right over here, it changes speed. So when it becomes faster, it bends more. So it becomes an angle over here, angle of reflection. The reflected ray over here, this part, and this is the incident ray. This is the declining ray, and this is where it adds speed and it bends. It bends because it got faster. And this is pretty much what refraction is. It bends by changing speed at a new median. And this is basically what explains how it is used and what it is, and explains it pretty good. And that's pretty much it. So hello, this is the last part. So it's diffraction. This is the explanation of diffraction. So what is diffraction? The definition of a diffraction, it goes around a barrier and it spreads out. Just like how you can see in this picture, I drew an example of it. This is like basically the doorway. It blocks the sight. So when like this is Jack and this is Mark. Mark is on the other side and Jack is on the other side. Jack is yelling at Mark. He can't hear him because over here it's blocked by the wall. This is the doorway. So this is the sound. I use this as the sound of Jack. So it goes through the doorway over here, and it spreads out like this as I have drawn up to Mark. So it goes through and it spreads out just like how the definition says. It goes around the barrier, which right over here we can see it goes around the barrier, through the barrier over here from the doorway, as I've drawn on as an example, and it spreads out. Right after it spreads out, as you can see over here. It went through the doorway, it squeezed through the doorway, it got out, it kept getting bigger and bigger and bigger and bigger until it reached Mark. So Mark can now hear Jack through this doorway. It's used the doorway and it spreads out up to Mark. So this is what diffraction really means. It means it goes through the barrier and it spreads all out until it reached Mark, just as we can see in this example.